Robonaut 2 lab. We're here with Josh Mehling, and I'm a little starstruck at Robonaut 2 that's standing right next to you. Can you tell me a little bit about your involvement with Robonaut 2?
Well, I'm the lead mechanical engineer on the project, so that basically means I'm responsible for a lot of the structural design and mechanism design. But the robot as a whole, here in this lab, we're looking at designing the next generation of robot that can work side by side with people and help make their work more efficient.
So you're saying side by side, not necessarily replace anyone, just side by side helping us.
Right, the whole design of the robot has been focused on something that can work safely next to people. The software, the controls, the mechanism, it's all about helping people be more efficient with their jobs.
Robonaut 2 looks like a human torso. Why is it set up like that?
If you have a human robot, it can use the same tools that a human can use. It can help assist humans, and it also moves in a way that's very similar to how humans use. So it's very easy for you and I to work with the robot and understand and try to visualize, well, how is this going to move? Whereas opposed to a standard industrial robot, it's a little harder to visualize that.
So we have tendons inside the forearm that pull the fingers in their various motions, and we have very similar joint structure to people. So we have the different degrees of freedom in the thumb and the fingers so that it all bends very human-like.
Us as humans, we can touch something and sense when we're holding something too hard. Would Robonaut not be able to do that?
Well, that's actually one of the main advances we've gone after in this robot is that sensing ability, especially that sense of touch. So throughout the robot's hand, we have various sensors that can give you a feel of the forces that you're exerting on the environment, the sense of touch of the things you're picking up, and that really allows it to take that next step towards doing those human tasks that you do basically by feel. It has a full 7 degrees of freedom, just like the human arm, so that gives you the ability to put your hand on an object and still give you the freedom to kind of move your elbow. And that's real effective when you're doing tasks and working side by side with somebody. So as you're doing something, you can keep your hands in the position that they need to be in, but you can kind of move out of the way if somebody's bumping into you, and it gives you that extra ability to kind of, be flexible on the fly.
What about the head, I guess I would call it? Can it see anything?
We have cameras built into the head, and it really is a powerful place for a camera platform. There's a reason why our eyes as people kind of focus in best on this work surface between the intersection of our two hands. And so we follow that same design structure with the robot. So we have cameras mounted right where it makes sense for them to see what the hands are doing.
Really, when you're looking at tasks that you want to automate, the 3 types of tasks that are prime for automation are applications that are dull, dirty, or dangerous. These are the kind of things the kind of environments that you don't really want to put a human in. These are the kind of things that robots can assist us with and really help make our jobs easier and safer.
Well, so there are a variety of different control methods you could use with the robot. One of them is somebody using a joystick or virtual reality equipment to move the robot through motions. And then you can, on top of that, build levels of computer control, autonomy, so that the robot can think and do actions on itself. There's a whole range of how you can control the robot, whether it's pre-programmed, whether it's learning from its environment and doing tasks, or whether you're controlling it with a human in the loop.
So this is Robonaut 2. There must have been a Robonaut 1. What are the differences between 1 and 2? In
Robonaut 2, we've gone for faster actuators. It's about 4 times faster. It's a little bit stronger, but the real advances are in the dexterity and the sensing. So especially in the hands, it moves a lot more human-like. It can make better grasps, and it has a variety of different sensors, so it can better learn about its environment, not just through the cameras, but also through its sense of touch. And that is good for doing tasks. It's also good for being very safe around people. Is the idea to keep only the top half of the body, or is it going to have legs as well? Right now it's sort of a modular design. We've got an upper body, and you could add legs onto it. You could also add other lower bodies. You could put it on a wheeled platform for handling rough terrain. You could put a zero-G leg on it so that it could climb around the outside of the space station. It basically leaves options open for different lower bodies for different operations.
So can you give me some future real-world applications for the Robonaut 2 robot?
Sure. We see a lot of technologies from this robot being applied to our cars and also in our plants, and really just the idea of humans and robots interacting safely and working together to do a better job.
Wherever we're sending people, wherever we're trying to perform some science or do some work, whether it's on the space station or on the moon or Mars or wherever we might go, we're looking to take the robot and assist in those types of missions. And it's not just the robot for the robot's purpose, but it's also the internal technology can be applied to other things we're doing, whether it's computer control, autonomous vision, force sensing. It's a wide application of things beyond robotics also.
I know you said you are an engineer, and your background, you actually worked on Robonaut 1 and now Robonaut 2. Did you ever think you'd work on a robot growing up?
Well, I think that was probably maybe always a dream from the time when I was playing with Legos as a kid, but I mean, it's hard to imagine a more exciting job. It's really like big kid Legos, right?
You're watching NASA Edge, an inside and outside look at all things NASA. Can I get one of these at Best Buy?